Hi, everyone. My name is Ashley Spell. I am the Director of Education and Awards here at AIA Chicago, and it is my delight to welcome you to Overcoming Barriers to Mass Timber Adoption, today hosted by the AIA Chicago Tech Issues Knowledge Community. I'm thrilled that you're all joining us today. This is going to be a fantastic panel. Before we get started, I'd like to thank and celebrate our 1869 Circle partners who have generously invested in the Chicago architecture community through support of AIA Chicago programming at the highest level. They are Constantino, Gensler, Getch Partners, HED, Leggett Architects, Lighting Protection Institute, Longboard Architectural Products, Pat-Clad Peterson, Perkins and Will, Schuller Shook, theater planners and lighting designers. And we are excited to share that there are more to come. So thank you and stay tuned. And now I will turn it over to what you all came for. Here is Callie Verkamp with Wheeler Kearns Architects. She is one of our co-leaders of the Tech Issues Knowledge Community, and I'll let her take it from here.
Thank you, Ashley, and thank you to everyone for joining us today. I'm going to be moderating a panel discussing mass timber and adoption in the United States. And to speak to this issue, we have brought together three amazing panelists who are all experts in mass timber construction, but who importantly have different backgrounds and areas of expertise within that field. I'm going to briefly introduce our panelists, and then they will have a few minutes to kind of further explain their background and their roles, and then we're going to move into the panel discussion. If anyone has any questions about mass timber, please feel free to go ahead and start dropping that into the chat or the Q&A, and we'll be sure to try to get to those at the end. Our first panelist is Dr. Maria Laguarda-Mallo. She is a licensed architect in Uruguay, and she specializes in innovation and mass timber construction. She's a project director at VIATechnik and has managed large prefabricated projects, working closely with real estate developers, architects, general contractors, and subcontractors from different U.S. regions in all aspects and phases of design and construction. Our next panelist is Calum Dodson. He leads Structurlam's mass timber business in the Northeast and Great Lakes. He holds a Bachelor of Science degree in Engineering Management and a Master of Architecture degree from the University of North Carolina, Charlotte. Calum has played a pivotal role in the East Coast mass timber industry for the last 5 years. And our third panelist is Erica Spiritos. She is Vice President and Director of Pre-Construction for TimberLab. And at TimberLab, she provides project-specific expertise to support appropriate and optimal mass timber design, estimating, and procurement strategy. She's an expert in mass timber project delivery with deep supply chain knowledge and a passion for sustainable wood sourcing. So I'll hand it over to Maria first, and she'll give us a little bit more background on herself.
Wonderful. Well, thank you so much for the introduction, Callie, and thank you very much for the invitation to the AIA team. And also thank you to all the attendees for joining us today. Really appreciate your time. As Callie mentioned, my name is Maria. I'm a project director at VIATechnik. Originally, I'm a licensed architect in Uruguay, where I worked for my first few years of my career and started my specialization in innovation and mass timber construction. Over the past 12 years, I've been working with mass timber, either on my doctoral research at the University of Minnesota, the Bioproducts and Biosystems Engineering Department, and also currently in my position at VIATechnik. My research was focused on the willingness to adopt mass timber by the US AEC industry, looking into the level of awareness and market potential, and some of the main factors affecting the willingness to adopt these systems in the future. And now at VIATechnik, I have been helping clients in the adoption of BIM and virtual design and construction processes. And over this past few years, I have managed teams of engineers, managers, and BIM specialists on larger architectural and MEP related projects, working very closely, as Callie was mentioning, with real estate developers, with architecture firms, general contractors, and subcontractors. For those of you who are not so familiar with VIATechnik, we are a technology solutions firm supporting the construction industry. Our firm seeks to transform the analog world of design and construction into a digital platform that enables efficient design and industrialized construction and the digital real estate service models. We're transforming the way that we'll build, and we're capitalizing on the digital twin technology by using real world data that creates simulations that predict how a product or a process will perform. We're a team of over 180 employees across several offices across the US, also Poland and Philippines. And over the past 10 years that we have been around, we have been involved in over 2,000 projects. One thing that really differentiates us from other companies like ours is that we care a lot about numbers, as you can see on this slide. And one thing that, that really we believe is that what can be measured can be improved, and that is part of our culture and part of how we deliver results and how we advance in the way we do business. When we think about the way that we add value to our clients is through our three-pronged approach of strategy, execution, and enablement. The strategy is all about making sure that the BIM strategy is aligned with the corporate strategy. The execution side of things is around implementing solutions. So basically creating 3D, 4D, 5D, 6D modeling, supporting digital fabrication, making sure also that the BIM to field link is strong to really get that benefit. And last but not least, enablement. That's really what we really care about, and we want to feel the value of that strategy and that enablement broadly through that training and that support to our clients after that execution. And we do that whether through VIATechnik University, one of our platforms, or through in-person training.
Great, thank you so much, Maria. Next we have Calum Dodson.
Thanks, Callie, and thanks everyone for taking the time today. My name's Calum with Structurlam. Personally, I fell in love with mass timber in 2017 when I had to complete a thesis in architecture school. And I went straight into the industry after that and have been in it ever since. Before Structurlam, I was with two other manufacturers. And, Structurlam, I think we can go to the next slide here. Structurlam first got into glulam in the 60s. So a lot of experience behind Structurlam. And then we were the first to introduce CLT into North America as a manufacturer. And since then, we've completed about 250 projects, or 450 projects, sorry. And we just commissioned our second facility in Arkansas. So we have two facilities, one in the Pacific Northwest and one in the Southeast. And so that's kind of my background for Structurlam there. Thanks, Callie.
Thank you so much. And last but not least, we have Erica Spiritos.
Thanks so much, Callie, and thank you to AIA Chicago for inviting me to participate in this panel. And thanks to all the attendees for taking time out of your day to be here. My name is Erica Spiritos. I have been working on mass timber projects and trying to push the industry forward for the last 7 years. I live in Portland, Oregon, and in the last 5 years or so, I've helped to launch a mass timber business out of Swinnerton Builders, a nationwide general contractor headquartered in the San Francisco Bay Area. Some of you may be familiar with Swinnerton. They've been operating since 1888. And in 2018, they decided to launch a mass timber division that would operate as a specialty subcontractor to Swinnerton and to other GCs. So I was hired to help grow that group. And since then, we have We have branched out as a separate business entity. So no longer Swinnerton Mass Timber, but now we are TimberLab, and we've grown to about 45 people in a couple of different offices in the United States, delivering projects all over the country. And we're a mission-driven company. We're focused on accelerating the mainstream adoption of mass timber in the US commercial construction market for the benefit of the planet and its people. Go to the next slide. Our business model is structured in such a way to deliver services that address pinch points and bottlenecks in the mass timber supply chain. So we focus on building in-house timber engineering. We offer pre-construction support. We do in-house virtual design and construction, so translation of the design intent into fabrication level information. We work with the manufacturing community all over North America and Europe to procure mass timber components. We do glulam fabrication in-house at our facility in Portland. And then as builders, of course, we like to install all of our own projects. And we believe that this delivery system gives us a tremendous amount of feedback. As you can imagine, we're touching each piece 6 times and learning a lot at each step of the way. And we learn a lot to be able to incorporate lessons back into future projects. So we've had the great pleasure of being able to work on many different projects all over the country. You can go to the next final slide. We have recently delivered the tallest hybrid mass timber tower in the world, the Ascent Tower in Milwaukee, Wisconsin, just nearby to Chicago. So maybe some of y'all have visited this building. And then a number of other civic, commercial office, higher education, and residential buildings together. I think we've completed over 25 mass timber structures in the last just four or 5 years, and really excited about where the industry is going. So I'm glad to be here to share my experience and insight with all of you today.
Great, thank you so much, Erica. All right, well, we can just dive into some questions. We can probably stop sharing the screen for now. And then, like I said, if anybody has questions, please feel free to put those in the Q&A. So we have a lot of architects and engineers in our audience today. So, you know, some designers or engineers might be interested in working on a mass timber building, but perhaps hesitant to suggest it due to a lack of experience working with this type of structure or a lack of familiarity with the process. What is your suggestion to those designers or engineers on just how to start? Like, what's the first step?
Well, I think if I may kick us off, I think information is key to really become, you know, confident on how to use the system. I think that it's super important to start by getting to review case studies, speak with manufacturers, reach out to industry colleagues. For example, Erica or Calum here that have experience working with mass timber and can provide feedback on what the next steps could be or what are the challenges of you know, working with the system. I think that all that information really becomes super important to gain that confidence on, you know, how to talk to an owner about, you know, the potential of using the system, or talk to a contractor on how to perhaps build it, right? So getting informed is, for me, always the first step to really adopting the system.
Do you think, and maybe this question will go to Calum or Erica, do timber design buildings require a different procurement process than a traditional kind of design, bid, build approach that many people are familiar with? And can you speak to that?
Yeah, I would say 100%. It's a different approach, but I think, you know, just over the last year, many different verticals have changed in their approach and like, you know, early procurement requirements, not just mass timber. But within mass timber, you know, we're in a moment of time where there is a lot of demand, and the current supply is struggling to keep up with that demand. So there are now more than ever, you know, requirements to get involved early with a trade partner or a manufacturer for, you know, to get in the door for production, but also to get all of the pre-construction design and submittal process, you know, completed appropriately.
Yeah, I agree with Calum, and I think another aspect of mass timber delivery is in the opportunity to optimize or really take advantage of the full prefabrication potential of the system. And a design bid build process doesn't allow so easily for the necessary overlap between design and construction. And in that overlapping phase, we are translating the design intent, the 100% construction documents even, or if we have the opportunity to start earlier than we do, into fabrication level information. And that's not just for the timber structure, but it's for other follow-on trades as well. When we talk about the schedule savings associated with a mass timber building, you know, people say 20, 25% compared to a concrete structure. That's made possible not just by the speedy installation of the timber, but by the smooth, efficient, fast follow-on trade work as well. And that's facilitated by prefabrication of penetrations for mechanical, electrical, plumbing, fire sprinkler systems, so that those trade partners can come into the building, possibly having already prefabricated their own hardware and just plug and play, because they're not doing any surveying, they're not doing any layout or coring of the structural system, and they can really be quite efficient on site. And that prefabrication of penetrations is only made possible with the virtual design, through the virtual design and construction process. And trade partners need to be on board early. So the timber trade partner, mechanical, electrical, plumbing, fire sprinkler, any other structural systems like a steel brace frame, concrete shear walls want to be modeled, facade wants to be modeled. And the more information we have, the closer we can get to like harnessing the full prefabrication potential of the system. But it does involve early buyout, early award of multiple trades.
Thank you. So with this early buyout, early award process, what is your recommendation for our clients who still want to make sure they're keeping bids competitive and getting the best value throughout the process?
Yeah. Go ahead.
I was just going to say it's a bit of a catch-22. Like if you wait to the last second and you know, to bid everything out, thinking you're going to get the most competitive price, you're going to lose all the efficiencies that Erica just spoke to. Mm-hmm. So that's why we're seeing in mass timber, you know, more and more like early RFP packages put out, so that a client can, you know, validate or weed through the, you know, the opportunities or the options out there. So it's not with the current state right now of the mass timber industry and all of the demand. It's not just about finding the best price. It's about finding the best partner that can deliver on kind of all of the entire life cycle of what a mass timber building requires. And then furthermore, it's schedule. So it's, you know, now I see a lot of clients like that caring less about price and more about schedule. When can you deliver, you know, even 12 months out? Like I see, so there are a lot more variables than just the price, I would say.
And I think to add to that, it's always important to really think that mass timber is not simply a material substitution, right? It really requires a holistic approach that everyone needs to be committed to from the start, like Eric and Calum were saying, to really get the full benefit and from the opportunities for efficiency in terms of materials, construction, that it allows, and also getting all the stakeholders together, including the manufacturer very early on, allows the team to make key decisions on planning, on design, and on even operation of the building very early on in the life cycle of the project, which allows for issues to be addressed quicker and more effectively early, when the cost is relatively minimal to really make those changes. If we're going into construction and we're trying to, decide on some of these changes, it becomes really costly, and we're seeing a lot of delays during the construction. So the way to really avoid all of those risks is basically, let's start engaging everyone early on during the design phase.
Yeah, I would offer maybe a slightly different perspective. I think there's, or maybe a more nuanced perspective, which is just finding this really delicate balance between bringing on a partner who can support the progression and the evolution of the design, but not procuring material at the wrong point in time, making a financial commitment at the right time, and then also being cognizant of the fact that manufacturers are not going to be able to hold lumber pricing for a year necessarily. And so when you bring them on board early, you're sole sourcing your design, but there's still the opportunity for price fluctuations given the market. And so as an industry, we are struggling to deal with that. We're all subject to the commodity price fluctuations of lumber. And the way that TimberLab has gone about dealing with this landscape, this kind of commodity landscape of lumber, the main component of glulam and CLT is to take on as much kind of manufacturer agnostic work in-house, so that we can progress the design to a place where a manufacturer can just go, and not relying on manufacturers for the design management and design completion. So doing all of the in-house virtual design and construction gives us flexibility in being able to competitively bid the package at the right time, because we do all the shop drawings in-house. Doing fabrication also takes that CNC machining off the kind of critical path in a way, so that we can work with manufacturers who either don't have CNC machines or manufacturers for whom CNC machining is the bottleneck in their process, and almost always it is the bottleneck. The industry, as Calum has said, is going to be stressed over the next couple years as demand is growing, which is so exciting. And so we all have to come together and find creative ways to deliver these projects, which are growing in number and in size, right? So I think there's lots of business models that are out there, and it's up to a project team to find all the necessary pieces and put it together in the right way. And there is no one right way to put the team together. Each kind of configuration of the project team provides benefits and challenges, right? So I think there's a lot to consider, but there is a huge amount of support and resources available to people who want to embark on the mass timber journey. And it's a leap of faith to do it for the first time, but I think once people do their first project, there's like really no going back.
Great, thank you all so much. this is kind of on a different subject, but you've all completed a lot of different mass timber projects in different regions. Do you think that there's an ideal building size, program, type that works the best for mass timber construction? Or is there, types of projects that should be avoided when considering this type of system?
So if I may, I think from a material standpoint, typically mass timber systems become more cost effective for applications where concrete or steel are typically used. One thing to consider is, for example, in programs where wood frame makes more sense, for example, low to mid rise buildings, mass timber has very little opportunity to compete because it requires more wood, and typically there is already a market for wood frame systems there, so it's harder perhaps to compete. However, when we compare it to concrete or steel for high rise or longer span applications, that's really where mass timber shines. It provides savings in terms of schedule, in terms of labor cost, and even the foundation cost, because buildings tend to be lighter and require smaller and shallower foundations. So I think that perhaps those are the type of buildings that I would see more applicable for mass timber.
Yeah, I mean, I think every year the industry kind of pushes the envelope for sure, since 2012 or whatever. I would say, like, given the demand in the market now, like very small projects will struggle. Even if it's an applicable project for mass timber, they will struggle just because, people out there like Structurlam, and I'm not going to speak for TimberLab, but like the amount of work to put a small project through the system is somewhat equal to a larger project. And because there's so much demand and supply is dried up, like, there's a little bit of picking and choosing out there, I think, from manufacturers that's taking place. So smaller jobs might struggle. But yeah, I think I agree with everything else Maria said. Yeah.
Mm-hmm. Great, thank you guys. So we're in Chicago, and I know, Maria, you are in Chicago as well. And we've recently modernized the building code to be more in line with the IBC. However, some of the more stringent requirements, such as floor and wall assembly fire ratings, have remained. How have you seen code prescriptive fire ratings addressed through mass timber construction, either in Chicago or in other municipalities?
So I think that it's definitely an important topic. I have to admit I'm not a code expert, but I have seen mass timber really still being used, perhaps in some cases with gypsum board with that sort of systems attached to it, not exposed, to kind of help with the fire resistance, the fire ratings in those areas, and that has been a way that we have been able to use in many cases mass timber in areas where fire is a concern. But I would love to hear from Erica or Calum to see what other communities have experience in this regard.
Yeah, I could share some of my experience. I think there, Chicago is one of a number of jurisdictions that has scar tissue from large fires that have swept the city, and so the building code is structured in a way to keep us all safe from big events like that. And granted, mass timber behaves differently than wood framing, but there's still a kind of a shift that needs to take place before people really understand the difference in performance between those two systems. So we have to be patient, these large ships take a lot of time and effort to steer in a different direction. But I will say that jurisdictions that seem to be more conservative are still accepting either third-party certification from different products, or they're looking to see product-specific or project-specific fire testing. And that information is more and more readily available. So even Chicago's standards and tests, has kind of a set of questions that they ask to, prospective mass timber project teams to validate the fire performance and fire and life safety associated with the mass timber structure. And we have the means to be able to answer all of those questions right now. So that's exciting. It's definitely more work up front, and there's risk associated with that process because the response is, unknown, and there aren't too many precedent projects in Chicago right now. But I think there is a process and there's a pathway forward.
Great. Kind of on that same line, being that, these systems are relatively new, some may question the qualifications and availability of a local workforce to install a mass timber structure. How have you seen this challenge addressed, perhaps in other municipalities, not Chicago?
Yeah, I think a couple of things come to mind. I can just speak a little bit from the builder's perspective. The installation of a mass timber system is not rocket science. And there are a number of training systems, including with the Chicago Carpenters Union, to equip subcontractors with the skills and experience to erect these buildings. So there's training available, and really the key to success in the field is in all of the planning that's done early on. So the work that's done at VIATechnik or, at Structurlam and TimberLab to do this kind of virtual construction gives us so much confidence about what the experience is going to be like in the field. I mean, we're basically building the building twice. We're building it to millimeter precision in a 3D model. We're going to fabricate all of those components based on the model. And then really the construction is meant to be an assembly of a kit of parts with a very detailed set of instructions that go along with it. I think the bigger challenge that maybe people don't always think about is that as these buildings get bigger, the financial requirements of a subcontractor become harder to meet. So like to build a 100,000 square foot residential or office building may not be something that a small timber framer can financially back, right? And has the financial strength to, they might not have the financial strength to buy that package. And so we just have to think about different procurement strategies, delivery methods in order to make sure that we're all protected, the general contractor, the owner, the subcontractor, the manufacturer, that everyone's financially protected. But I think there's another thing I'll say is that there are install crews who are traveling all around the country to build these buildings, and even coming from Canada into the United States to erect these structures. And so I think to get the momentum going in a certain city, it may take bringing in an out-of-town crew to build the first couple of structures. Then they maybe train some of the union carpenters in the city, or they start to train people in the city, and then the workforce develops over time.
Great. This is a question from the chat, which I'll go ahead and ask because it's kind of along these same lines. Do you anticipate more general contractors starting to self-perform mass timber installation as it gains wider adoption?
Yeah, I think we're going to see all types or all opportunities for install grow. I mean, steel erectors are looking at it. You know, as Erica said, there's a lot of expert installers that have originated where the industry sort of originated in the US and the Pacific Northwest. Those teams are growing. And yeah, GCs that want to self-perform, I think that's going to definitely accelerate as well. I think there's a lot of, you know, business opportunity for GCs to do that. And so, yeah, I think definitely.
Calum, one other question for you. You had mentioned market demand for mass timber increasing and, you know, some issues with supply. How can developers reduce their risk on procurement and establish schedule assurances with manufacturers?
Yeah. So our strategy in approaching that issue is basically via early award, design assist, or specialty engineering engagements with our clients. So we get involved with the project around design development, you know, with a specialty engineering contract, where we can, you know, ensure the project gets, you know, maximum utilization of all the wood fiber, the wood structure, the wood components. Meanwhile, we're already penciling the project in the production queue 10 months down the line. And by awarding the project early to a manufacturer like Structurlam, you know, we can control or sort of ensure that the connection details are efficient and efficient from a production perspective and a assembly perspective on site. But yeah, I guess to summarize, like via early award, we're then able to pencil the project into production and make sure that we can meet the client's schedule through the process.
Great. So yeah, it's kind of back to that early engagement topic that we discussed at the beginning. And you've all kind of addressed efficiencies that can be realized when there is an early engagement with a manufacturer. Can you speak more specifically to what efficiencies you're talking about there?
Yeah, so it starts, you know, with the structural grid and aligning that grid to the materials that the manufacturer makes. I mean, it's not quite as standard as steel because it, you know, originates from a tree, which, you know, there's different types of species, different types of strength grades, so different types of products. So if you have the approach where you're going to design the building generally for the industry, you're not going to be seeing that extra 10% utilization of the wood fiber, like really driving down the wood volume per square foot. So you need to understand who is making your products from the beginning in order to get that extra utilization. And then additionally, it's down to the connection design. I think that's a big driver. You know, 20 to 30% of the total package cost could be connections. And obviously that changes with the change of steel pricing, but that's, you know, ensuring that the details are A, easy to build and B, easy to install. That's gonna have a huge impact on the success of the project.
And I think a key part of also making sure that we really leverage those efficiencies goes back to what Erica was mentioning earlier on, building that digital twin before we go into the job site, making sure that we account for all the MEP penetrations, anything of that sort that you know, may impact the structure during construction is key to make sure that, you know, we have everything, you know, ready for when construction starts, and that construction process can go as smooth as possible without any type of risk, any delays, any surprising risk, costs that, you know, we may not have foreseen.
Great, thank you guys.
And maybe to be just super specific here, I agree with everything Calum and Maria are saying. Typically, we find that the best time to, the earlier the better you can bring on someone to provide feedback. So if you can engage a mass timber trade partner or manufacturer during schematic design, that's where you're gonna see the most potential cost savings, because the biggest cost driving decisions are made in schematic design. The grid, as Calum's talking about, the construction type selection. But I would say the team doesn't necessarily need to buy out or make a commitment to a trade partner in schematic design. It might be best to wait until, like, typically we find the best time to do that is like around the end of design development. But once you get into construction documents, you start to lose the opportunity to gain both schedule efficiency and design efficiency. When we talk about this digital twin process, that's really a fourth phase of design, because 100% construction documents are just not fabrication ready. But what we try to do is do that digital twin work in parallel with the construction documents phase, so that the construction documents develop to reflect in a way that reflects what will actually be manufactured and built. So if we do the whole design in a design bid build procurement, we do the whole design 100% CDs and we put that out to the market, we miss that opportunity to overlap the digital twin with the CD phase. And then we expose ourselves to the risk of some redesign, because some of the details that were developed during the CD phase may not be ideal.
What do you think is the most common challenge encountered with projects that are trying to implement mass timber? And do you have any advice or lessons learned for how to avoid these, major challenges for people that are looking to implement this type of structure?
I think we've kind of covered on like the potential risks and sort of the strategy to avoid them. Mm-hmm. So like, yeah, not design, bid, build, because then everything that Erica just spoke about happens, and there's always redesign, always redesign in that method. And depending on who the engineer was, the details might change like completely. The whole structure could change a lot. And then, by delivering that type of building with mass timber, you're not gonna be able to de-risk schedule or provide any schedule assurances. So yeah, I think we've covered off generally like how one should approach delivering mass timber successfully. And if not, then there's just, there's risk for schedule delays and cost impact.
I would agree with Calum. I think that we talked a lot about, the biggest pitfalls of not getting teams to buy into the system early enough, not getting manufacturers involved early enough. I think the other point that I think it's also important to mention is communication and collaboration are key. Making sure that these projects are successful, making sure that we don't have silos of information, that everyone is able to work with the latest information absolutely all of the time, that there are no gaps of information or people holding information from other stakeholders. That's going to be key. And I admit that works for other type of building systems as well, but I think that when we're talking about a prefabricated system like mass timber, I think it becomes imperative to really focus our energy on ensuring that collaboration and communication are at the forefront of the project.
Do you guys think that mass timber structure is kind of an all-in proposition, like all or nothing, or have you seen hybrid structures being implemented throughout the United States?
They're all hybrid to one degree or another, whether the podium is concrete, the first few floors are concrete, or the shaft is concrete, or the brace frames are steel, the connections are steel, or you have a whole steel hybrid with cast in place concrete shaft, steel post and beam, and then CLT decking on top. I think you can find all of those options out there, and I think they're all viable, depending on the specific location and the project need.
Erica, do you have any specific experience building within a seismic zone with mass timber?
Oh yeah, I'm in the West Coast, so that's most of our projects are designed to be earthquake resilient.
Can you just kind of briefly speak to how you've accomplished that with mass timber structures?
Sure. So mass timber systems actually afford us a number of benefits in a seismic zone. The lightweight nature of the system means that the lateral system design is less robust than it would need to be for a concrete or steel structure. The structure itself has to resist less force during an earthquake because of its lighter weight. And typically, mass timber structures are designed to fail in an earthquake event at the connections. So we're paying specific attention to what the interface is between panels, beams, or columns, beams, and panels. And so there's a lot of testing that goes into understanding drift capacities of different connection systems. And then of course, thinking about diaphragm design as well is an important factor. We are able to use CLT as the horizontal diaphragm, even in seismic zones. Occasionally the steel strapping gets a little bit heavier, more heavy duty in higher seismic design categories. And then almost always, unless we're working, in a two-story building or something, we're using a concrete or steel lateral system, vertical lateral system, with just higher ductility than what has been proven with CLT or glulam, for example. But yeah, totally doable. And even the most stringent jurisdictions are accepting these designs.
Thank you. All right, we have about 10 minutes left. So Lee, if you want to jump on, we have several questions from the audience, so we'll get to those.
Great, yeah, thanks everybody. And I think most of these questions actually answered, but I will go through some here that I think we didn't cover. So one was just said, last I heard timber prices are up 400%. How has the industry navigated this in terms of adoption in this economy? Do you foresee prices and supply chain lightening up in the future?
Yeah, well, I think prices in every industry went up significantly over the last year and a half, and things are sort of leveling out. I'd say in a lot of different industries, with mass timber especially, the lumber prices are coming down. I think there were unprecedented drivers that drove it to historic highs. But there's also the seasonal cycles that the mass timber industry or the lumber industry goes through. And that's, historically high in the winter, and then it, starts to come back down into the summer, which we're starting to see happen now.
Great. Yeah, it's funny because I think we titled this presentation Overcoming Barriers to Mass Timber Adoption. And it's funny you're saying, well, the demand is actually growing. And I'm not sure if that's just, maybe partly because people are starting to see the success stories of it, but also just the buzzword of sustainability, right? And timber being an innovative design. And it seems like with demand growing, really the barrier would be more, and correct me if I'm wrong, more related to getting so that owners and architects and designers become more knowledgeable as the demand is growing, and not just doing it for the sake of doing it, but that, you know, there's a whole different sort of procurement in this. Is that kind of what you guys are seeing? Seeing a lot of head nods, so okay. Another question was, how are insurability challenges being overcome, both with builder's risk and fixed property?
I can speak to that a little bit. So as I mentioned before, you know, people hear mass timber and they think wood, and then they think light frame construction, and they think, oh God, my building is kindling and it's just going to go up in flames, or at least that's what the insurance community hears. And so there's been years of education of the insurance industry to help them understand the differences in material behavior between mass timber and light wood frame construction. And that just because wood is a combustible material or timber is a combustible material doesn't mean that these buildings aren't designed to have fire ratings, and in fact can be designed to have the same fire and life safety performance as type 1 construction. And I know they're concerned about other things as well, the newness of manufacturing and the risk there, and then also just water, potential water damage. Those are some of the top 3 concerns that I hear. But there are insurance carriers that are starting to offer packages for mass timber. Zurich has offered a package of up to $50 million for mass timber buildings, which is amazing because historically you've needed, general contractors and owners have needed to kind of cobble together insurance for mass timber buildings from multiple different carriers, and that's challenging. So it's going to take time, but the insurance community is coming around, and a big motivator for that is like the new actionable goals around like climate change solutions. And we are motivated to innovate to try and protect our planet and future generations from climate change. So there will start to be a shift, but in the past, I wouldn't be surprised, don't be surprised when you see higher premiums associated with mass timber compared to concrete and steel. That will change over time. It should level out, but it's definitely been, it's been an effort.
Right. No, that was a great explanation, and right along the lines of global warming and being sustainable. The next question is, in terms of carbon emissions, what are the most exact numbers comparing engineered timber structure emissions? This is including drying, gluing, steel connections, finishing, etc., compared to usual concrete steel frames in general. I don't know if you guys would have those exact numbers, but have you guys done any general comparisons?
There's a lot of content out there available on this topic with woodworks and other entities, but I would say that it's just like you can't even compare it to concrete and steel, because mass timber is a tree grows from the sun, and the building becomes a carbon sink, whereas steel and concrete is made by a completely energy intensive process.
Yeah, it turns actually to be a carbon sink, right? So instead of releasing that carbon to the atmosphere through that manufacturing processes like with concrete or steel, we're actually capturing that carbon within that structure. So that's really what we would love to see for other materials as well. But Erica, perhaps you do have some some numbers.
No, I'm on the same page. I was actually just reading the International Mass Timber Report that Forest Business Network published this year. They do it every year, and they have a whole chapter about carbon analysis, and it's called There are many models, all of them are wrong, some of them are useful. And I really just think that's so well put. There's so many assumptions that go into calculating carbon. And so like to ask about exact numbers for stored carbon, embodied carbon, carbon footprint, I think is just setting ourselves up for failure. But there are a number of ways that we can think about the impact associated with mass timber, substituting timber for a more carbon intensive product like Calum described, the biogenic carbon associated with the timber that Maria is talking about, that opportunity for the timber to store carbon because wood is 50% carbon by weight and it stays in the wood structure as long as the structure is standing. So there's a common sense aspect to it. There are definitely systems out there, but once you get into like the nitty gritty assumptions of those software kind of calculators, you realize there's a lot that remains to be explored. And so we have a couple of resources we can use. We have environmental product declarations that manufacturers do have that kind of documents the carbon associated with the manufacturing process. We can look at forest practices associated with the wood that we're sourcing. Certifications are helpful with that. Also just like transparency. So understanding where the wood is coming from allows us to learn a little bit more about their management practices. But what's really amazing is that because we care so much about wood, we're starting to ask really important questions about where the wood is coming from. And hopefully that can spark conversations about other materials as well. And that's a beautiful thing because as a community, we will, in this greater awareness, we will make better decisions about our designs and our procurement strategy.
Oh, that's great. Those are all great answers. This one might be a little bit quick. Is there any software to model post-tension cross-laminated timber other than open seas? So it sounds like we have some modelers out there. If you guys have any program recommendations for post-tension cross-laminated timber?
Not from my side.
Sorry.
Yeah, I don't have experience with that.
Are there any incentives in the public realm for constructing with mass timber, or are these typically built with only developers and clients who are committed to the construction type?
There are definitely some incentives. The USDA and the US Forest Service offers a wood innovation grant every year. This year, the Softwood Lumber Board also provided grant money to the mass timber community. And then there are cities that are launching specific programs to try and incentivize low carbon construction. So I know Boston, for example, has spearheaded a mass timber accelerator program where they're providing funding to support the extra kind of R&D or permitting expenses associated with mass timber. And it's possible that there are other cities who are doing similar things.
Awesome. I had a couple questions as we were going through here. One of them was, most of our participants are architects and engineers, designers. What are some maybe recommendations you would have for how an architect or engineer can provide qualification requirements for fabricators or installers?
Mm. I mean, I think you're looking for a partner you can trust. And so past experience is a great predictor of future performance. So always asking for people's past experience and then also asking for references, calling people's references. I think it's important to ask for financials as well. When talking to manufacturers and installers, you want to make sure that, especially for large projects, they're capable of carrying a package of that magnitude. going to visit is an awesome way to get a sense of like capabilities and how different groups operate. So if you have an opportunity to go visit a manufacturing facility or go visit a project that a certain installer is working on, I think that's great. You'll learn so much just from that. Those are a few of my ideas.
Yeah, just understanding, you know, years in the industry too. Like as the industry continues to grow, there's going to be more and more manufacturers, and there are newer ones, and then there are older ones, and some of the newer ones that I've been a part of in my life, you know, kind of learn on the job, and that's not necessarily what a client might want. So, you know, understanding how long the company's been producing mass timber is the first step.
Mm-hmm.
Do you think there will be, you know, certifications in the future, you know, for that maybe architects and engineers can say, hey, you know, this company needs to be certified XYZ, that they can write almost in their specs to make sure that those qualifications are met, on top of obviously, you know, the interviews and the experience that you guys are talking about, but just some sort of other insurance, you know, from the baseline spec level.
You mean aside from the manufacturing standards? Because there's already like industry-wide manufacturing standards, I think, that are intended to sort of provide, you know, that level of, what's the word?
Right?
Yeah. Yeah. Like you have the PRG 320 for CLT and the ANSI A190 for Glulam. And I think, you know, I think that's a baseline. To be in the industry, as a manufacturer, that's a baseline.
Totally.
Great.
Yep.
Well,
Great.
thank you all so much. We're at time, so I'll go ahead and just wrap it up. But Maria and Calum and Erica, we really appreciate you all sharing your time and your expertise with us. And I know we have a lot of really interested audience members in this subject as well. So really appreciate everything. And thanks to the AIA for hosting this as well. This has been great. So, and this will be posted online, the recording, for anyone who's interested in rewatching or sharing. So with that, we'll kind of wrap everything up. But
and Callie, everyone has our contact information if they need it, right? Through.
Yeah, if anyone does, please reach out. We can provide that, definitely.
Well, thank you so much for the invitation again. And great talking to you guys.
Thank you. Thanks,
Thanks,
Callie.
everyone. Have a good afternoon. Thank you.
Bye.